Action.
What is moment of inertia? Well, you've all seen the formula. It's equal to the mass times the distance the mass is from the rotation axis squared. But what is it? Well, it's the inertia for rotation. So, for example, if I hold this guy in the middle, the mass is, well, it's, half a meter from, well, a little more than half a meter, a full meter from each side. And it's not too difficult to rotate. This would be my pivot. This is the rotation axis. But if I hold it on the end, it's very difficult to rotate. And the reason for that is all of the mass now is farther, and that quantity gets squared. So the distance it is from the rotation axis is very, very important. Let's take another example. I have here two objects. One is a hoop. So all of the mass is a distance r from the rotation axis. It should be right through the middle. Here I have a solid disk. The mass is evenly distributed. So clearly this one has a larger moment of inertia than this one, because all of its mass is at this full distance r squared, whereas for this guy it's distributed equally, so you have to do some average, but clearly the moment of inertia is less. This guy resists acceleration, I should say, resists rotational acceleration more than this guy. So we expect this guy to win the race. Sure enough. Woohoo, the winner! One last thing on moment of inertia, and this is just to tease you a little bit, but it can get very interesting the deeper you go. Here's a very simple object, and I'm going to rotate it in three ways. I can rotate it like this, along this axis. I can rotate it like this, along this axis. And finally, I can rotate it like this, along this axis. Now, this one has the largest moment of inertia because, and I should hold it like this, because you get, some of the mass is at the diagonal. So it's at a farther distance. And don't forget, it's the distance is squared, so it's the biggest effect. Whereas this one, well, that's the smallest moment of inertia because the mass is, a small distance away from the rotation axis. These black lines mark the two rotation axes in this plane. And then this one, rotating it like this, well, that's right in the middle of the other two. Now watch what happens as I rotate them three ways. This way, very stable. Now I'll rotate it along the smallest moment of inertia. This way, very stable. Now let's try the moment of inertia in the middle. Not stable at all. The smallest perturbation throws it off. I'll let you think about that one and maybe come back to your physics teacher.